All right, so today we're going to be working on exponent review. So again, this is all review, so this is not like brand new information or anything like that. When we did sequences, that was brand new, and that was something you guys had to know for your CASP exam. So we went through and taught that. But this is going to be review, all right, how to deal with powers and things like that. So a couple of things that I need to remind you guys about. When you have negative powers, okay, you can rewrite them as positive powers as long as you kind of flip them either from the denominator to the numerator or numerator to the denominator. So you can see both situations right there. If you have an x to the negative n, you can make it a positive n, just flip it, okay, put it in the denominator. So 1 over x to the n. If your negative power happens to be in the denominator, you can bring it up, and it'll just basically lose the denominator, just become a numerator value. So 1 over x to the negative n will just become x to the n, okay? Another thing you guys have to remember is when you have the same bases, so the bases are the letter x. So if it's like 2 to the third and 2 to the fifth, that type of stuff. And when you're multiplying them, you're going to be adding their result, okay? So you're going to get m plus n. Add that stuff together. Now, if your answer happens to come out to be negative, then rewrite it so that it's a positive value, okay? Or if you're dividing, so if you're dividing the same base but with different powers, x to the m divided by x to the n, you're going to subtract, okay? And there's one more, well, there's I think 2 more things I want to go over in terms of review with the properties you're supposed to know with exponent. If you have something like this, let's say, well, let me leave it like this, xy to the n. Remember, you can distribute that power, so it's x to the n, y to the n. Okay, and then the last thing is going to be powers to powers. So if you have x to the m to the nth power, it's x to the m times n. All right, so those are all the properties. I'll put kind of dots right here so you can see where they start off. But in order to do this, you're going to have to know all these properties for today. Okay, again, these are all review. I think you learned this sometime like in your 8th grade, 9th grade, maybe before that, depending on when you took your algebra stuff. But these are properties for exponents with algebra. Okay, so in question number 1, let me kind of go back up to look at the instruction. It says simplify. All answers should have positive exponents. In other words, if you have some exponents, when you multiply them, the result is a negative power. That's fine, but just fix it, okay? Just fix it. So let's go ahead and start off with number 1 here. So number 1, we have 3x squared x to the negative fifth times 2 x to the 0 y squared. So I always deal with the numbers first. So 3 times 2, that's going to give me a 6, okay? And then I have x squared times x to the negative 5. Now remember, when I multiply the same base, I'm going to add the powers, right? So 2 plus negative 5 is what? I'm adding these. That's a negative 3. Yep. And then I'll go with the y's. Now notice, y to the 0, what is anything to the 0 power? It's not a 0. It's a 1, right? Anything to the 0 power is a 1. So you could rewrite it if you want to, or you could just say, well, y to the 0 times y squared, that's 0 plus 2, that's 2. Right? So you could either do y to the 0 equals 1, or you could just add the powers, right? 0 plus 2 is 2. Now, my answer is correct, but according to the instructions that they'll tell you on the CASP exam, they don't want any negative power. So that x to the negative 3, I'm going to use the very first thing I wrote in green up on the top. If I have a negative power, I'm going to flip it to the denominator and make it positive. So this becomes 6y squared over x cubed and then I'm done. Okay, so there is my answer for this problem right here. It's not a terribly difficult problem. It's just there's steps, right? You got to multiply the numbers in front. Then you got to multiply the bases that are the same. So the x's, the y's together, right? And then you don't have to do anything else other than that unless you can simplify something. But in most cases, if you do it in the right order, there won't be any simplification required at the end. So there's going to be a lot of problems like this. Like I said, we're not doing all of them. We're just doing some of them. So here's another one. So notice how example 1 was a multiplication problem. This is a division problem. So that means instead of adding the powers, you're going to be subtracting them. Okay? You just got to be careful though when you subtract, because sometimes you get negative numbers and you're subtracting negative numbers. So in actuality, you're adding, right? So we'll kind of take this a step at a time. Now, with this problem, I'm going to do the same thing. I'm going to deal with the main numbers first. I have a 3 in the denominator. On the numerator, I have a 1. It's not there, right? But it's a 1 over 3. There's nothing I can do to simplify that, okay? So I'm going to just basically write a fraction like this, and I'm going to leave a 1 and a 3 there for now, okay? Then I'm going to deal with my a terms. Okay, I have an a to the first divided by a to the third. So if I may, I'm going to actually write it out as a subtraction. 1 minus 3. Okay? And then I have a b to the second divided by b to the negative 4. So that's going to be b to the 2 minus negative 4. Again, I'm showing steps here. A lot of times people don't want to, and that's okay. If you don't want to, you don't have to. A to the 1 minus 3, that's a to the negative 2. So again, I'm going to write a fraction here, a 1/3, a to the negative 2. And then I'll fix everything at the end. And then b to the 2 minus a negative 4, that really becomes a 2 plus 4. So that's going to be b to the 6th. So I'm basically done. I just got to fix that negative power. A to the negative 2 is going to go down. It'll become an a squared in the denominator. So I'm going to write b to the 6th over 3a squared. Notice I did get rid of the 1 on the top because I don't need it. 1 is just a placeholder, but there is something there already, so I don't need to show it. If you want to, that's okay, but it's not necessary. So there's my answer for number 2. Okay, b to the 6th divided by 3a squared. So there's going to give you like 5 problems like this to do. Okay, they're going to look very similar to this. There's one kind of challenging problem, which will be the 5th one. It's going to be a multiplication with division in it. So just take your time, multiply and then divide after. But the skills I went over right now will help you do number 5. Okay. Now from there, when you flip the page over, they're going to have you do solving of equations. Now, when you solve equations like this, there is a property that you guys need to know. So I'll kind of write this one out for you here. It's basically this. If you have x to the m equal to x to the n, I should probably put this. If this is the case, then m is equal to n. So if you can get the bases to match, the numbers on the bottom, the bigger numbers, I guess, if you can get them to match, then all you have to do is get the powers and set them equal to each other, and then solve. Okay? So you'll notice for number 3, my bases match, right? 9 to the power of something equals 9 to the power of something. The 9s match up, which means, using this definition, I can actually solve this thing right away. Now I'm going to do this 2 different ways, okay? I want to show you guys 2 ways to approach this. So I'm going to put it right here. I guess I can put part A. So 9 to the x plus 6 equals 9 to the negative x. Because sometimes we need to kind of change some stuff. So I'm going to show you the easy way to do it, which is right now. And then maybe what you might have to do in the next example, which I think you do have to do in the next example, which is to kind of change some stuff around. So Since the bases are the same, that means I can just get the powers. X plus 6 equal to negative x, right? I can just set the powers equal to each other. And then I can start solving for my variable. So I'm going to move my x over to the right side. I know I like keeping things positive, but since the 6 is already on the left and the x is on both sides, I'm just going to move the x to the right. So that means I subtract it. That comes out to 6 equal to negative 2x. Now divide, bless you, I'll divide both sides by negative 2. So x is equal to negative 3. And that's going to be my answer. All right, so that's one way to do this. All right, probably the easiest way because of the fact that they already have matching values. Now, I do want to show you one other thing that you can do. And it does make it a little bit more difficult, but it does occur in your state testing. Okay, so I want to show you guys, and we've done this in class, but I want to show you guys another way you could approach this, which is like this. Let me put it right here, part B. Because there's a lot of people who the base, so you see the 9s, those are called our bases. They don't like to leave them as composite numbers. In other words, they don't want them to be numbers that can still be divided. So they want to break them down into primes. So 9, they want to write it down as a base of 3. So 9, they can write it down as 3 squared x plus 6 equals 3 squared to the power of negative x. I know this looks a little bit tougher, but sometimes it's useful to break it down a little further. And you're going to see that in example number 4. Okay? But you can break it down into 3 squared and 3 squared. Now, the thing that you have to remember is there is a property that basically says powers to powers are products, right? We did that, right, where is it at? Right here. A power to a power is a product, right? So, for part B, you see I have a power of 2 to a power of x plus 6. I have to multiply these. So this becomes 3 to the 2x plus 12. This becomes 3 to the negative 2x. Now my bases match, right? 3 and 3. I know they matched before, and you might say, why the heck did I do all this? But I'm just trying to show you a different technique, because sometimes it's needed. So the bases match, so I'm going to set the powers equal to each other. 2x plus 12 equals to negative 2x. And now if I move the 2x over to the right side, I get 12 equal to negative 4x. And if I divide both sides by negative 4, what's my answer? Yeah, same solution, right? So I didn't get anything wrong. I did kind of work a little bit more than I needed to. But I just wanted to show you guys that you can break down the bases as much as possible to try to find matching bases. Now, I know we had them initially. So like I said, you might say, why would I do that? I wouldn't. I wouldn't do the blue part if my problem looked the way it did right now. I wouldn't do that. But sometimes the numbers don't match up, so you might have to break them down into their primes, okay, into other numbers. So this is what I'm talking about. So you see 2 to the negative 3x plus 5 equals to 64. All right? So obviously 2 and 64 are not the same base, but I can write 64 as a base of 2. 2 to what power? Try to work that out. 2 to what power is 64? So let's see. 2 to the first is 2. 2 to the second, that's 4. 2 to the third, where are we at? 8. 2 to the fourth, so 8 times 2, 16, right? 2 to the fifth, well, that's 16 times 2, it's 32. 2 to the sixth, that's going to be 64, because 32 times 2, 64. So it's 2 to the sixth. Okay? So at this point, I'm going to say my bases match. So therefore, my powers can be rewritten as an equation. Okay. So now just basically get all your terms and solve for them. Remember, fractions exist, so if you get a fraction, don't freak out. Just check your work to make sure you didn't mess up to create a fraction. But I'm going to move the 5 over to the right side here. So negative 3x is equal to 1. And then I'll divide both sides by negative 3. So I get x is equal to a negative 1/3. We okay with that one? One more example to kind of go over. All right. And then there's going to be some problems like this, and this is going to be the last one we're going to do. Then I'll give you guys your assignment, and the rest of the time is for you guys to try to get that done. But notice we do have a product there. I want to remind you guys of the property x to the m times x to the n. That's one of the very first ones I wrote. That's equal to x to the m plus n, okay? If the bases match and you multiply them together, the bases don't change. What I'm basically trying to say is 4 to the negative x times 4 to the negative 2x minus 3 is not 16. It doesn't come out 16 to a new power. The 4 times the 4, the big numbers, they stay the same. The bases don't change. The powers do. Okay? When you're multiplying the same base, the bases won't change. The powers do. So I usually get people that make a mistake and they multiply 4 times 4, make it 16. Then they're like, oh, look, 16s match. Right? Not supposed to be like that. Right? In other words, this is just going to be, I'm going to write the step here, okay? 4 to the negative x plus negative 2x minus 3. That's what's supposed to happen on the left side. When you get bases and multiply them times the same base, the base stays the same. So the 4 is going to stay the same. The powers are going to be added though, because I'm multiplying the same base, you add powers. So negative x plus negative 2x minus 3. So, and then the 16, I didn't write it there because I want the bases to be the same. 4 and 16 aren't the same. What should I change 16 into? So that the bases match. 4 squared. Okay? Now sometimes people say, well, couldn't I have gone to 2 to the 4th as 16? Yeah, then you just have to change the 4 into 2 squared. But that just makes it more difficult. But we just did that. That was the blue part that I did, right? Not that you have to do that, but you could if you want to. I personally would not, just because you're just making it more difficult. But it's possible. Not a big deal. So now our 4's match. So let me clean up the left side real quick. That's 4 to the negative 3x minus 3 equal to 4 squared. Okay, I just added the powers really quick. And now since the base is matched, that means the powers can be set as an equation. So negative 3x minus 3 is equal to 2. I'll move that minus 3 over. So negative 3x is equal to 5. And then I'll divide both sides by negative 3. And I'm going to end up with the fraction, but like I said, that's okay. Fractions are fine. Okay? So here's your answer for that.